Hey Math Kids, today we're going to talk about the derivatives of exponential functions. And so if f of x is equal to b to the x, then the derivative is equal to the derivative at 0 times by the original. Okay, and so if we extend that just to e to the x, if f of x is equal to e to the x, and if f of x, or f prime of x, is equal to itself. So the derivative of e to the x is e to the x. So we're going to do some examples using that. So we have 2 e to the x plus e to the negative 3x. We have x squared e to the negative x and e to the 2x over x. Okay, so we can do these both separately. This first piece, if we take the derivative, is exactly the same. Just have a constant out in front, doesn't change the derivative, and then the derivative of e to the x is e to the x. Now, when we have a different exponent that's not just x, we're going to rewrite the original, and then because of the chain rule, we're going to multiply that by the derivative of the exponent. So in this case, whoops, that's too big. So we bring that down, and that's just negative 3, because the derivative of the inside was negative 3. So overall, that is the derivative of that function. Okay, now this next one, we have something multiplied by something else, so we're going to have to use the product rule. So we take the first one, multiply it by the derivative of the second one. So the derivative of this is going to be e to the negative x times by the derivative of the inside, which is negative 1. Now I'm going to just rewrite the second one and multiply it by the derivative of the first one. And that is the derivative. I guess we could simplify it, bring this negative out in front. Something like that. There's a number of different ways we could write it, but let's just leave it there. Okay, this one could be quotient rule. So we take the, let's get some space. So this is our u of x, or here, I'm going to use the high and the low. So the first thing is the derivative of the top. Now let's go back to I take it back. Let's do the u and the v. Okay. So u of x, v of x, and then u prime of x and v prime of x. So v prime is just 1. U prime is going to be 2e to the 2x. And so our quotient rule, we do 2e to the 2x. We times that by v, which is x. Then we subtract, we times it by u, e to the 2x. And then we times it by v prime, which is 1. And divide that by this squared. So that's our quotient rule. And so moving on to the next one. We're asked to find the gradient function for y that is equal to this, as well as okay, so this is just going to be a chain rule. So we bring 3 down, rewrite the inside, drop the exponent by 1. Now we need to multiply by the derivative of the inside, which is just e to the x, because derivative of e to the x is e to the x, and the derivative of negative 1 is 0. This one we're going to rewrite, so it's up top. So it's going to be 2e to the negative x plus 1 raised to the negative 1/2. So we didn't take the derivative, we just rewrote the original. Now when we're taking the derivative, we bring this down in front, rewrite the inside, drop this by 1, and then multiply by the derivative of the inside. So that's going to be negative 2e to the negative x. Okay. Now we have a new formula that we're going to be using for non-e to the x exponentials. And so if we have y is equal to a to the x, and where we know that a is greater than 0, then dy dx, or y prime, is going to be a to the x natural log a. So if we're given y is equal to 3 to the x, and y is equal to 5x squared minus x, what we're going to do here is just use this formula. So you take the original and then just do natural log of the base. So in this case, 3 to the x is the original, and then natural log of 3. And so this is our dy dx, or our derivative. Now coming over here, we rewrite the original, and then we multiply that by natural log of the base, which would be 5. And then because of the chain rule, we have to multiply this by the derivative of the inside. And so that's the dy dx of that, or the derivative. If you have additional questions, please come to Math Lab. Until then, calculator.